Hey everyone, Tony here with Emergitech. Today we're going to follow up where we left off in our last video and look at performance of Windows versus WSL2 by training a modified ResNet 50 model on both platforms, while also testing the performance of the underlying file system for each of the platforms. If you remember from our last video, our interest in running TensorFlow on WSL started when we experienced low GPU performance while training models on Windows platform. While that problem has been fixed, we are still interested in building models in Linux. The problem we're going to look into today is file system performance on WSL. This is a high-level view of the WSL2 architecture that Microsoft has developed. The underlying problem could be with Linux kernel, or something with how 9p is implemented, or it could be something completely unrelated to either of these. It's hard to nail down the exact problem, as I haven't found any post that has a solution for the problem other than this post from Microsoft found on GitHub, which basically says, yeah, we know there's a problem, but we're working on it. The goal of today's video is to at least narrow down the symptoms. So here's a setup for our test. We have a tower system with Windows 10 Home Preview Edition from the Microsoft Insider program running on a tower PC with an X399M Tai Chi motherboard that's provisioned with an Intel i7-9700K processor, 16 gigs of RAM, a NVIDIA GeForce RTX 2080 Super GPU, and 3 drives. We won't be using the system or the C drive, but instead using a standard hard disk drive or the D drive and a PCIe integrated Western Digital solid state drive. Both of these drives are 1 terabyte. For the model training, we'll be using a modified ResNet 50 model. Here's a graphical representation of the model. It has 48 activation layers along with 4 dense layers. This model is not accurate yet, with 92% prediction accuracy rate on randomly generated images. This model does require a significant amount of data to train. Also, before I get 30 million comments about image load efficiency, no, I am not using prefetching. The intent here is to look at performance of the OS, not Keras or TensorFlow load efficiency. And I didn't want to cloud what's going on between TensorFlow and the OS with another layer of abstraction that I would need to drill down into for an understanding about what's going on in the environment. Yes, prefetching will help, but if there are still I/O bottlenecks, the help it brings is only relative to the prefetching performed on other platforms. For those of you with keen eyes, you probably notice this is a classification model with 54 outputs. We are using this to identify playing cards. I started with image capture from an iPhone of each of the playing cards, including jokers, which gave us 54 unique 3024 by 4032 by 72 dpi images. I then used Keras' image data generator along with Pillow image module to create randomly generated 260 by 200 by 96 dpi images of each of the playing cards. All of this yielded 2 sets of images, each set containing 54 directories for labeling purposes. With 750 unique and modified images of each of the playing cards for training, and 500 unique and modified images for each of the playing cards for validation. I also generated an additional 500 unique images of each of the playing cards for prediction purposes. But since we are only going to execute 5 epochs in this test, we won't be using those prediction images, as the model will not have been sufficiently trained for accurate predictions. So our testing will cover 3 environments: Windows 10 Home, WSL2 Ubuntu 18.04, and WSL Ubuntu 20.04. If you remember from our last video, we had issues with the CUDA toolkit in 20.04. So we will only be able to test this performance in 20.04. However, we may be able to extrapolate TensorFlow model training performance based on what we see from Windows and Ubuntu 18.04 testing. There are a number of potential approaches to measure disk performance. The problem is creating a reasonable correlation between 2 different operating environments on the same infrastructure. Take, for example, using WinStat in Windows and DD in Linux. You can't take those outputs in megabytes per second and make correlations between the two because the underlying actions are different, even if you specify the same parameters such as block size. So what we're going to do is use xcopy with Windows and monitor with a measure command in PowerShell, and in Ubuntu, I'll wrap the cp command around time to give us execution time. Unfortunately, we can't use perf in Ubuntu because it's not supported in WSL. Now, is this going to be a precision test of disk performance? Of course not. But what it will do is give us a comparative view of what's going on between WSL and Windows. Our test will then comprise of copying 39,000 files, making up approximately 325 megabytes. Now, regarding training on an ext4 environment, with the large amounts of training data needed, it would be impractical to try to test this within the Ubuntu environments. With over half a gigabyte of data needed for one data set, it doesn't make sense to copy it from one environment to another, then have to replace that data every time I need to rebuild a Ubuntu environment. Best practice is to keep the data on a mounted volume where it can be shared amongst all the environments. However, once Microsoft fixes the automount issue in WSL2, then I can test it on an ext4 formatted drive. I'm not going to bore you by making you sit through each of the tests, but speed them up and combine them so we can spend time looking at the results. First, I performed the training test on Ubuntu 18.04, and here are the training results. It covers the average of each of the steps in the training, as well as the average of the total epic runtimes. Next, we trained on Windows. And here's the training results for Windows, again with the step and total time averages. Next, we'll look at disk performance. Here are the disk performance metrics for Ubuntu 18.04 and 20.04 on both of the drives. Finally, the disk performance test results on Windows. Looking at these results, what pops out immediately is the disk performance on WSL2. It's pretty clear we have an issue, and it occurs in both Ubuntu environments on both drives. Symptomatically, it certainly helps to prove the fact that there actually is a problem with the underlying file system that's impairing the training speeds on WSL2. It's interesting, though, that the Seagate outperformed Western Digital marginally on Ubuntu 18.04 in the copy test. I suspect this may be an anomaly, and we'll test it again on an 18.04 clean environment when I have some time. Also, it's interesting to note that the training times were only marginally different between the two drives on Windows 10. I suspect this may be tied to the Anaconda environment. There are performance improvements that can be made, especially with prefetching and with package pruning. When I'm able to track those down, I'll let you know what performance improvements were made as an update to this video. As I was training the models, I had Task Manager up to monitor GPU temperature, and to make sure that I was training on the correct drive through monitoring disk activity. Task Manager did pick up on activity on both of the disks, respective to each of the training being performed on them, especially during the first epoch, as you would expect. And speaking of GPU temperature, it was clear that the GPU engagement with TensorFlow on Windows 10 was much more intense, given the differences in GPU temperature recorded. In Windows 10, I observed between 65 Celsius and 70 degrees Celsius, while on Ubuntu 18.04 it ranged between 55 degrees Celsius and 60 degrees Celsius, possibly indicating a lower overall calculation throughput on the GPU on Ubuntu 18.04, which would make sense if the system read performance was hindering the feeding of data into the training execution, thus slowing the overall throughput into the GPU. So this test pretty much validated my assumptions that the file system in WSL2 was at least the symptomatic culprit behind poor training performance. I'm not interested in figuring out what the underlying problem is, as I'm focused on developing models, not solving underlying OS problems. I could build a custom kernel, as there are several features that I could tweak, but honestly I don't have the time to chase down configuration changes that would have any kind of positive impact on this issue. At this point, I'll just use WSL for automation and scripting and file manipulation, but continue to build and train on Windows. If you like this content, please give this video a thumbs up to support the channel, and please consider subscribing for further AI content. I thank you all for the kind support, and I'll catch you all next time.